All right. So we're talking about living with radiation. We talk about natural radioactivity. We talk about man-made radiation. We talk about how we discovered those things. But it's just true. It's just true that we've been, and we are, and will forever be embedded in, a world where radiation is just part of our lives, right? So we need to understand what we mean when we say radiation, okay, and how the word radiation can mean many things, right? And how that's different than talking about the harmful types of radiation that we're going to focus on in learning about X-rays, okay? So to be clear, radiation, the word radiation means anything that transfers energy from one point to another in space. That's it. Radiation is energy moving from one spot to another. That's what we mean. Now, the forms that radiation can take are varied. Radiation can be in the form of particles. We mentioned things like alpha, beta particles earlier, which were discovered by Becquerel and identified by Rutherford. We take for granted sound, right? Sound is a form of radiation, yeah.
So the alpha, beta, and gamma, those are natural?
Those are types of natural radioactivity. Now, to be very clear, when I just said particles, I didn't mention gamma, right? I mentioned alpha and beta. Alpha and beta particles are particles. Gamma rays are a type of wave like X-rays are. We'll clarify more on that later, not necessarily today. But alpha and beta particles are particles. This little meter here, every time it clicks, okay, what is it showing? What does it say? 20, say something counts per minute? 33 counts per minute? So that's detecting natural background radiation. That's detecting the decay of radioactive nuclei. And when those nuclei decay, they emit pieces of themselves, and those pieces are hitting the gas chamber inside of that meter, generating a small electric current, and the meter clicks audibly every time that happens. Every time a radioactive decay event is happening, a particle of radiation is hitting that little gas chamber, the meter's telling us about it. This is observable and detectable by the use of that meter. Let me finish this page, and then I'll show you a way that we can see particulate radiation at work, okay, because it's really cool. Okay, so there's particles. We'll talk more about this in a second. I think it's so neat. By the way, you have about 5,000 atoms in your body every minute that have a decay event. So you are radioactive, okay? Smoke detectors are radioactive. Your bananas that you eat are radioactive, right? And so radiation is just around you. Particulate radiation is just around you to begin with, okay? Doesn't mean it's not harmful, but it is around you. That meter is counting it right now. Mechanical waves are a type of radiation. Waves in a medium. So mechanical waves are waves that travel through a medium, right? The air in this room is a medium between me and you guys, right? What does that allow me to do? That allows me to vibrate my vocal cords, change the shape of my mouth with my tongue and my cheeks and my facial muscles, and send some sound waves to you, and you can understand those sound waves as me talking, right? That's mechanical radiation. That's waves through the air. Okay, you can go into the ocean or a lake or a pond or a puddle or my cup of coffee, and I can boop my cup of coffee. I can drop a little pebble in my cup of coffee, right? I can go into the ocean and I can stand there and I can get hit by waves from the ocean. That's all mechanical radiation. Yeah. Like when a tsunami occurs in the ocean, that can come from something like, for example, an underground earthquake, right? Big underground earthquake shakes the ground, makes some waves in the ocean, and sends those waves traveling at fast rates of speed towards land, right? And that's where tsunamis come from. That's mechanical radiation. The best example is sound, yeah.
So the mechanical radiation, are those harmful to us?
It depends. They're not harmful in the way that we're trying to talk about today. But yeah, I mean, you can weaponize sound. You can make sound so high frequency that it hurts people's ears, right? The military has done that. They have devices that are sound cannons that can send high... Is she okay?
Yeah.
Okay. That can send high frequency sound waves towards your ears and blow out your eardrums, right? It's crowd deterrent stuff that they use for, deterring mobs and things like that, rioters, whatever. So harmful, yes, but not harmful in the way that we're going to talk about as far as harming like your cells and stuff like that.
Is that how mechanical waves? Is that how? I don't know if you've ever heard of bone conductors.
Bone conductors?
Yeah.
Like,
Like
conduct, yes, it's the same thing.
Is that what that is?
Yes.
Because I always was curious on how that even like transferred information from people that can't hear but
Yeah.
can understand.
Yeah, the vibrations are just traveling through the skull and being read out by, you're talking about cochleal implants.
yeah.
That's sending stimulations to the cochlea, stimulating the cochlea. Where the sound, because you lose the conductive sound, conductive hearing loss, so sound, really quickly, sound waves hit your eardrum, vibrate your eardrum, 3 small bones, the malleus, incus, and stapes in your middle ear, those bones all move when your eardrum moves, right? Those vibrations through mechanical movement are transferred to your inner ear, which is then transferred and converted into electric signal. So conductive hearing loss is like, for example, when those little bones become arthritic and aren't able to conduct vibrations any further, and so you can sort of circumvent that. Yeah. So the mechanical radiation, a really great example of that is sound waves. Sorry, real briefly. Running low on a battery. This thing used to be able to go like 24 hours, now it goes like 2 hours. Yeah, did it go up when I got near it?
Yeah, sure did. Wonder why.
I wonder why. I knew there was something off about that guy. All right. Right? We never see me with the lights off. Electromagnetic waves. Okay, so this is the one we're going to spend the most time talking about and trying to understand. It'll be the subject of the very last class session for physics towards the middle of December. Electromagnetic waves or electromagnetic radiation comes in the form of things like visible light, radio waves, X-rays, infrared, which is felt as heat, ultraviolet, microwaves, right? You know about all these things, right? You know about microwaves. Where do we use microwaves at? In our kitchens, right? We use microwave radiation inside of our microwave to cook food, right? We use ultraviolet light to get tan, yeah? We experience infrared when we get next to our oven and feel the heat from our oven. Okay, that's infrared light. We experience radio waves when we turn on our car's radio, right? We experience X-rays when we use our X-ray machines and create X-ray images of the body, and we experience visible light all the time, right? So that's electromagnetic radiation. So let me briefly